Welcome to day 19 of our class. Today we're going to do a quick overview of the trends in renewable energies, specifically looking at nuclear, wind, hydropower, solar, biofuels, and geothermal. And then we'll take a look at what the renewables are likely to be in 30 years from now using some different renewable energy forecasts. Let's start off with nuclear. So nuclear power ramped up in the United States rather quickly in the late 1960s through the 1970s and early 1980s. It quickly reached a maximum capacity in the late 1980s and has remained roughly constant since. As we've talked about in class, that's primarily due to the lack of options for the long-term storage of nuclear waste. If we look at what nuclear contributes to our renewable energy, that is actually 20% of our electricity actually comes from nuclear in the United States. So if we were to lose that renewable nuclear energy, then we'll have to replace it with something else. So here's part of the problem. Because we haven't been building nuclear power plants because of the long-term storage issues. In fact, only one power plant has been constructed in the last 20 years. Most of the power plants are getting quite old, and so 48 of the power plants are currently between 40 and 49 years, and some of these plants will be reaching the expected operational end and will need to be decommissioned in the near future. So which nuclear power plants are going to be decommissioned? Well, between 2013 and 2025, 14 nuclear power plants are slated to shut down. And there are 2 in California that are quite sizable and some in the eastern half of the United States. So on the left, we essentially have our projections for what nuclear capacity and is going to change over time. And so if we allow these facilities to be phased out without replacing them new, the long-term forecast for nuclear power is a continual decrease in the capacity of electricity generated by nuclear power. And on the right, you can see that we have some projected retirements that are coming up, some rather large ones coming up in the near future. Let's talk a little bit about wind energy. So right now the mix of wind energy is primarily onshore, and the reason is that it's a lot cheaper to install power onshore than it is offshore. Even though there's a lot of area that's available for wind power offshore, just the infrastructure requires more money to make it work. So let's take a look at onshore. Well, up through 2019, the onshore was growing quite rapidly. It's up to 542 gigawatts installed capacity, and it was growing at a rate of 21.3% per year, moving at that direction. And then moving forward, the projections are a growth rate of about 7.2% with, by the time we get to 2050, with over 5,000 gigawatts of installed power, which is about 9 times more than what we currently have. If we look at offshore wind currently only has 23 gigawatts. So it's significantly smaller, but it has been growing at a rate of 38.5%, and the projections are that it'll continue to grow at about 11.5%, and by the time we reach 2050, that we'll have about 1,000 gigawatts of installed offshore wind power. If we look at the price for onshore wind power, the levelized cost of electricity, it started off in 2010 at about 8.5 cents per kilowatt hour, and it's been gradually coming down. And by the time we got to 2018, it was down to 6 cents per kilowatt hour. And the projections are by 2030, it'll be somewhere between 3 and 5 cents per kilowatt hour. And by 2050, it'll be somewhere between 2 and 3 cents per kilowatt hour for the cost associated with these, making it very attractive. So how are they making it cheaper? Well, one of the ways that they're doing is that they're making larger wind power farms and individual capacity for the wind turbines. And they've done that not by increasing the hub height, which ranges basically since about 2006 has averaged just about 80 meters, but by doing it by increasing the rotor diameter. So rotor diameter is going up as well. So they're making these bigger so that they have more capacity. Let's take a look at hydropower. Well, right now there are 1,308 gigawatts of installed hydropower around the planet as of 2019. The largest fraction of that was in China, followed by Brazil, followed by the US, and then Canada, and then a lot of smaller contributions from other countries. It's only increasing at a rate of about 1.2% per year. And you'll see that those increases are not happening uniformly around the globe. If we look at the newly installed hydropower, you'll see that most of it is happening outside of North America. Very little hydropower is being established in North America. Most of it, the largest of these are happening in East Asia and Pacific, specifically China, South America, specifically Brazil. Are places that are adding lots of hydropower right now. If we look at it by installed country, here you can see Brazil has installed almost 5,000 megawatts, China a little over 4,000 megawatts, and Laos was almost 2,000 megawatts of hydropower in the last year. Let's take a quick look at solar power. So the cumulative U.S. solar installations has been rapidly increasing from very small capacity in 2010 up to a very significant capacity in 2020. And you'll see that there's growth in the residential, the non-residential, but particularly the largest growth has happened in the utility scale solar. And then there's also CSP, which is concentrated solar power. It's a different, it doesn't use photovoltaic cells, but it concentrates power, sunlight, in order to use it as well. And you'll see that this utility scale solar is really what's driving these huge increases. So where is this cumulative solar installations happening? Well, California is the dominant market for this, but all over the entire southwestern U.S. is going very strong in solar, as is the southeastern United States. The central portion and the northern portions are less so. And one of the big changes that's happening is the percentage of solar systems that are being paired with energy storage. One of the big knocks on solar power is that it's only available during the day, and it doesn't contribute to our energy availability at night. Well, if you pair it with an energy storage system, then that disadvantage is actually alleviated. And now, basically, as of 2019, very few of these solar power generation stations were paired with energy storage, but moving forward in time, it's anticipated that by 2025, about 25% of installed solar will have paired energy storage. So here we have a graph that's showing how the price of solar power has been decreasing significantly over the last 10 years. And it's now actually going to quickly become competitive with other types of traditional fossil fuel-based electricity generation. And the solar industry actually creates a variety of different types of jobs. By far, the dominant source of jobs, however, is for installation, but there are significant jobs associated with manufacturing, trade and distribution, a lesser amount for maintenance as well. Let's take a look at bioenergy. So there are different types of bioenergy, but in 2019, the largest sector was actually solid biomass, followed by biogas, and then renewable waste and others. So the U.S. biomass power, if you look at how it's been increasing, so there are three different types of ways to get energy out of biomass. You can burn it, you can do anaerobic digestion, or you can do gasification and then burn it. But by far the most common way is to actually create fuel and then burn it. And you can see that there's only slight increases in the amount of biomass power that's being generated each year in the United States, but it's slated to increase slowly over time. So if we look at which countries and which regions are key in the production of biofuel, well, in the U.S., we are a significant player in the biofuel market, but we're primarily producing biodiesel. And Brazil and China, on the other hand, are producing ethanol, which is essentially a gasoline alternative. Brazil is doing that because they don't really have access to oil, as does China, so they're using these food crops in order to generate the fuel as an alternative to petroleum oil-based products. Let's take a quick look at geothermal. Geothermal is one of those resources which is underutilized. We have a lot of geothermal capacity in the western United States, but very little of that is actually being tapped into, and there's not a lot of growth expected in geothermal unless somebody decides to invest heavily in the technology. And here we have two rather ambitious or optimistic viewpoints on where geothermal could be in 2025 and 2030 if there was significant investment in this resource. So let's take a quick summary of this. If we look at what's happening over time in terms of new electricity generating capacities, you'll see that solar is by far one of the largest. Solar and wind, or excuse me, solar and natural gas are the two largest of the new capacity that we have for electricity generation. And the natural gas is coming online as the coal-fired power plants are being phased out. We haven't had a new construction of coal-fired power plant in the United States in the last 5 years. Those are being phased out in favor of natural gas and renewables. And then for wind, we can also see that that's been increasing as well over time. So here we can actually see that we have significant amount of coal that is being phased out of production. That's the black line that's going, the black bar that's going underneath. We also have some oil and natural gas facilities which are moving offline as well. And then we also have nuclear power, which is coming offline. So in order to overcome those offsets, you need to have new additions. And you can see that the new additions are primarily being driven by solar, wind, and oil, or basically natural gas, are the three things that are being added to the system on a yearly basis. So if we look on the left, we have projections moving forward from 2016. You can see that the amount of electricity that's being generated by coal essentially goes to zero by 2050. Natural gas continues to be a significant but slightly declining contributor to our electricity generation, Oil is almost completely phased out now and will be very soon. Nuclear is slated to continue, but not to grow and to actually decrease slightly as some of the older plants are in fact phased out. Hydro is not expected to grow much at all either. And bioenergy has slight growth, and most of our growth of our energy production is really coming from the wind and the solar. So you can see that the projections for this is basically that by the year 2050, they anticipate that 86% of the electricity in the United States that's being used will be actually coming from renewables. And that is as opposed to right now, we have 83% of our electricity is being generated by fossil fuels. So that's quite a remarkable transformation that's slated to happen over the next 30 years. And the total installed power is expected to be dominated by solar power in 2050, followed closely by wind. Those would be the two dominant power sources in the United States. If we look at the costs, costs are continuing to fall for both solar and wind power. So in 2010, photovoltaic cells were over 35 cents per kilowatt hour, and they have been decreasing precipitously and are now down around 4 cents per kilowatt hour. Onshore wind was a lot cheaper compared to solar. In 2010, it was about 8.5 cents per kilowatt hour, and it's also down to around 4.5 cents per kilowatt hour. Solar has now basically just crossed over and is now slightly cheaper than onshore wind power. You'll also see the CSP. CSP is concentrated solar power, and it was quite expensive 10 years ago, and it is also coming down remarkably fast. These are commercial scale concentrators that will make use of concentrated sunlight to expand a gas, make steam, and then turn a turbine, much like the other energy production techniques that we've seen before. And just for reference sakes, the fossil fuel generated energy is generally more than 6 cents per kilowatt hour. So wind power and solar power are not only competitive with fossil fuels, they're actually cheaper than fossil fuels, which should have some dramatic market implications moving forward. So if we look at the renewable growth moving forward, between 2019 and 2024, it's anticipated that the primary growth will be on onshore wind and solar photovoltaic cells, with a little bit of hydropower being added, a little bit of bioenergy, and a little bit of offshore wind. But because onshore wind and solar are cost competitive and cost advantageous, that's where most of the growth is going to happen over the next 5 years.